Thank you. Thank you. Thank you very much. Thank you, Lisa. Thank you very much. Before I even start, I want to say that I got a tour of the library this morning, and I got to tell you, to the point, it's a real hidden gem. This is just a wonderful facility. It's the books here, the people here, and your facility, your infrastructure is really wonderful. So thank you very much for giving me the opportunity to be exposed to such a fine organization. I'd like to share with you the story about the development of the first digital camera and the development of digital photography inside of the Eastman Kodak company. And in the course of doing that, I hope to share with you some of the little-known aspects of the development of digital photography that was driven by Kodak, a film company, during the last 30 years. And also, I'd like to share with you some observations that I have made about doing what I would call disruptive innovation inside of established corporations. Doing it and surviving it, important aspect of it. Camera of the future. This is a story about the development of a digital camera. It was a portable device. It was completely digital. It took available light photographs and displayed them on a television set. And this was done starting in 1975. And although there were many demonstrations of this system during the year 1976 throughout the company, there was no public acknowledgement of any of this work I'm about to tell you about until the year 2001. Now, the part of this is I was in a research laboratory, and as part of the research laboratory, this was a project, a really very small project, but a project. And when I got done with this project, as was customary inside of an industrial research laboratory, you wrote a technical report, and I did, and a portion of it is up here on the screen. And although the technical report is about 100 pages long, it describes largely technical issues associated with what it took to build this camera. I did take a moment in the report to describe what I called the camera of the future. This was my attempt to try to describe what I thought the impact of this type of work might be in the future. Now, I would guess we have several hundred people here tonight, so if maybe a quarter of you actually read this, we'll double the number have done so in the last 30 years. Point number one, in terms of disruptive innovation, the message doesn't get out in technical reports, I'll assure you of that. So let me tell you the story and how it evolved. Innovation, in my mind, is a lot like a row of dominoes, where one development sort of kicks off another one, kicks off another one, kicks off another one. And the domino that kicked this off was the development of the charge-coupled device. An invention made by Boyle and Smith and Bell Labs in 1969. It was a way to move very discrete amounts of charge packets around on the surface of a piece of silicon and keep the integrity of those charge packets reserved. And that was first developed and invented, but the first devices really didn't come out until the early 70s. And so when an area device became available, it was very experimental. I was approached by my supervisor of the electronics group in a small industrial research laboratory that was part of the overall resource structure of Kodak. We were an applied research laboratory, so we did things like look at new product ideas, solve metrology problems for production line issues, things like that. And so he thought that this might have some application doing some measurements or something like that. Nobody had ever done anything with it before. He asked me if I wanted to play with this and see what I could do with it. So I gladly accepted that. Our conversation took about 15 to 20 seconds, as I remember. It was called a filler project. It was just to keep me busy between doing real work. And so I formulated a task. And I thought I wanted to build a self-contained portable device. We were very interested in the imaging capability of this device. I thought, well, if I'm going to do imaging capability, I could do some simple measurements like modulation transfer function, things like that. But I thought, wouldn't it be much better to try to capture sort of an image, because it was an area array. So I thought if I could build it and put it into a camera, a portable device, I could go around and take images of different things. And then I thought I had no way to look at the picture except electronically. There were no printers that could print anything continuous tone that was easily available to me. So I thought I'd have to display it on a video screen of some kind. And then being surrounded by mechanical engineers who were building cameras at the time, I thought it would be really fun to try to build it with no moving parts whatsoever. And that, I will tell you, was just me. Here's what the device looked like. It came in a package like this. It was made by Fairchild Corporation, and it was 10,000 pixels, okay? So it's 100 photosites by 100 photosites, matrix like that. So 0.01 megapixel in today's parlance. It had an architecture that allowed for interlaced output, because the people who were working on this were thinking about these to replace Vidicon tubes for television sets, and of course you need an interlace for that. So the architecture was sort of suited for that, even though the resolution of this wasn't even equal to television at the time. It had an area array of about 3 by 4 mils or millimeters, 120 by 160 active area. So it was reasonably small, which helped me an enormous amount with the optics. And then I must say it was difficult to work with. When you receive this device, this was several $100s, and was the only thing I was authorized to buy anything on this project for, was to buy this device. It came in a little plastic box, see, and that little chip was in some foam in that box, and on top of that chip came a folded piece of paper. And the folded piece of paper had 12 pre-printed voltage measurements on it, which were the voltage measurements supplied for the clocks to make it run. And then next to each one of them, handwritten in pencil, was the actual voltage this particular device worked at when it left the manufacturing line. And at the bottom said, "Good luck." And the reason was because this was really a device you had to put a lot of inputs and clocks to, shine light, just the right amount of light on it, and then you may get an output. And if you didn't get an output, you had to figure out what was wrong, because there was no way to do that. So they were very difficult to work with. Now, the approach I decided to take an all digital implementation. Now, I'd love to be able to stand up and tell you that I knew the whole world was going to go digital. But quite frankly, my training was sort of in digital. I had been exposed to it in some of the first projects that I had worked on in Kodak. But it really solved a big problem for me, and that was I was incapable of doing anything complex mechanically. I had no budget, I had no skills, and I had no tools for that. And so I thought if I could just freeze the signal using a digital approach, I didn't have to deal with any mechanical complexity. If you wanted to capture a still image back then, you'd have to use something like a helical scan mechanism on a VCR or something like that. And I just didn't want to deal with that. So I decided to go all digital. And what it did, I decided to construct it with a camera with a removable storage medium. Why? I wanted it to look like the cameras we were used to. Now, one of the things that you have to realize when you do innovation and you're inside is if you can make your idea sort of look like something that's familiar, it's a lot easier to have a discussion around the newness of it rather than being so different that you can't even have the discussion. So decided to build a camera where you could take out whatever the image was stored on and put it into something else. I also had to view this electronically, and so I had to build a playback device. Over half the effort that was in this project went into the playback device. There were no personal computers at the time, so we had to build everything from scratch, being in a completely digital frame store and display mechanism. And so a lot of work went into that. And then I want to mention here that I was working in Eastman Kodak Company, which had the most gifted people in terms of imaging there was anywhere in the world. I was a 5-digit extension call away from just about any aspect, any imaging expert in any aspect of photography of any kind. And I very often called up different people to ask rather strange questions, and they were more than happy to help answer the question. Now, the situation. You know, in a research lab, there's projects, there's big projects, there's small projects, and then there's like filler projects. These are the projects that they give you to keep you out of trouble until they give you something useful to do. So this was a very small project, and therefore it had no formal management review. There was nobody really asking how things was going or anything like that. We only had part-time help. I had the help, and I was so lucky to have the help of 2 technicians. In the beginning of the project, a fellow named Bob Diego, who really helped with some imaginative solutions to some of the mechanical aspects of this rather complex prototype we were building that allowed us to build a prototype that we could take completely apart and work on and yet fold up to be something portable. And then I had, on the second half and most of the project for the playback unit, a fellow named Jim Schickler, who was a helicopter pilot from Vietnam. He had come back and he was studying to be an engineer, and just a really gifted guy. And without these two guys, we wouldn't have had the success we had because they really provided some really insightful advice. We had no money. That was clear. I could buy the CCD and that was it. Since I wasn't really supposed to do anything much with this thing, I said they really weren't going to pay for anything else. And then the proverbial back lab. There really wasn't any space. You know, when you don't have a formal charter to do something for management, it's hard to get people to give you stuff, and there was no room. And so we literally had to clean out a back lab. You know, they say the back lab? It really is a back lab. It was a back. We had to clean it out, Jim and I, and we built it in this back of this long corridor where nobody knew we were. So in summary, our plan was unrealistic. Nobody was paying attention. We had no money, and hardly anybody knew where we were working. In other words, the situation was just about perfect. Now let me tell you a little bit about what a camera is made up of here. First, there's imaging optics. I'm not an optical engineer. There were lots of them at Kodak, but anything they did cost money. Fortunately, I was working upstairs from the XL movie camera line. That's where the Super 8 movie cameras were made. And it turns out that the active area of a Super 8 movie slide frame is bigger than the active area of the CCD that I showed you earlier. And so I thought, that was neat. So I went downstairs, and out of the used parts bin for the manufacturing line, I lifted an XL55 movie camera body that was broken. And I lifted, and the whole optics assembly and the aperture exposure control for the digital camera came from that. So that's how the optics came about. I mentioned the imager assembly, that's the CCD, but there is some special electronics that have to be built to drive this thing. It's quite complicated to get all the clocks right, and then you only get a very small voltage output on this, and it has to be amplified and held, and so there's a little bit of analog electronics that have to be built with it. Then there's the A to D converter. That is the device that takes me from the analog world to the digital world, from a sampled analog signal to a digital word. They existed back then, but they were very expensive because this had to work relatively quickly, about 5 microseconds per pixel or so. And so I couldn't afford to build one. Luckily, though, it was just that point in the development where they were making digital voltmeters, and there was this chipset that came out from Motorola that cost only about $25 to purchase, where it used a different technique than what flash was normally used. This was a successive approximation technique. And it allowed me for about $25 to build an A to D converter that would work for this speed in this camera. So that's what we did. The digital memory that was used to store the image when you first captured off the CCD, the biggest memory chips that were available at the time were 4,096-bit chips. 4,000 bits, okay? So those were the biggest. Those are the high-techest ones you could get. And so I had 10,000 bits, I had 10,000 samples. I was going to digitize to 4 bits per sample, and so I had 40,000 bits to store. So I had to have, I had to use about 12 of these. And so this is, that's what the memory card looked like in the camera. But in reality, you have to store to something more permanent because you need power on to store the digital information in that board. So the only form of a digital memory that didn't require a battery at the time was a digital cassette tape, and so that's what we stored it on. So those are the fundamental elements, and let me show you how they sort of go together here. What happens is it's basically a signal chain, and what happens is your light comes through your lens and goes through there. It gets exposed on the active area of the CCD, and if everything's working right and things are going well for you, you get an output. And the output looks a little bit like this. It's like a stepped analog waveform. It comes out, and for 5 microseconds you get an analog voltage setting, and it is at that point in time that the A to D has to grab each one of those and turn it into a 4-bit word. And that 4-bit word then is sent over to the in-camera frame store. Now all of this happens in about 50 milliseconds. That was the exposure time. So I would capture an image, it would be digitized and stored in this board in 50 milliseconds, okay? So relatively rapidly. But then, from that point, it was read out rather slowly to the digital tape cassette. And that took 23 seconds, okay? All right. Now, I show you this for a couple of reasons. One is, this is the fundamental architecture, as crude as this is the fundamental architecture that is used in digital cameras today. You might notice when you capture an image sometimes, it keeps blinking and says, wait a second before you can take another image. That's because that digital memory that's in there is stored, is full, or they're busy doing something with it, and they haven't put it to the permanent memory, which in modern cameras is flash memory. So it's the same idea of fast memory, slow memory, rapidly getting it out. The CCD and the imagers of today, the CMOS imagers of today, are wonderful transducers, but they're terrible storage devices. They can't store that charged version of the light that was on the scene for more than a couple of tenths of the second before it degrades. So you have to get it out rather quickly, and that's what you do. You digitize it and store it in something like that. And then we read it out rather slowly. And then the second reason I show this to you is because when we talk about the reaction to this concept, remember, all of this complicated stuff up here was being done, thank you very much, by a single piece of film that cost only a few cents that people were quite happy with. Okay, so when you talk about innovation, you have to take a look at what's already there. And people are saying, okay, very cool, what's that got to do with a piece of Kodak color film that I can buy for a few cents, all right? And the Kodak color film, by the way, stores the device and you can use it as a printing device as well. So that was the issue. After about a year, that's what resulted. Now, you've heard the expression, beauty is in the eye of the beholder. This was beautiful to me. The camera itself was about the size of a toaster. It weighed about 8.5 pounds. Took 16 AA batteries to run. The digital cassette, you can see that on the side. By the way, that digital cassette recorder, I found that in the back of a magazine. It was used for well logging. So it ran off of 12 volts. It was a portable device. It fit in my camera, so that's what fit in there. The picture capacity is 30. Now, I'll tell you, one of the reasons I could have stored hundreds of images on this cassette. I chose 30, a number between 24 and 36, because I didn't want to get into the discussion about storing hundreds of images on a portable removable device. It would have complicated the story. I knew it was possible. I could have done it on this one. But sometimes you have to keep your idea simple and straightforward in order to keep the discussion focused on the essential elements. You don't want to embellish it with other things that it can do later on. So that's why I set it at 30. It wasn't limited. I just did it that way to make it more comfortable for people to think about the idea. I mentioned the XL55 movie camera, and the design was foldable. Now, this is how the camera is pictured today. This is how I remember it. This is the device would unfold. All of these things would pop open and unfold because this was a prototype. There was only one built. Anytime we built a circuit, it was only built once in this camera. If it didn't work, we ripped it out and did it again in this camera. So it had to always be exposed. Everything had to be able to be worked on. And believe me, everything needed to be worked on. It didn't work very well for many times. But it would actually take pictures in this position. And that was some of the innovation of Bob Dieger did that. Just a couple of other photos. This is probably the first digital memory card for a camera. This was all hand wired by Bob Dieger. Yes, he did need new glasses after this. This was, he had to wire each one of these by hand because we had no money to make a board. So we didn't know if it would work, so we just did that. This picture I took just a few years ago now. And I just wanted to show you this because this just shows you the nature of how this thing went together. These little gray things in the front are potentiometers. You'll see they're individually adjustable for that CCD, the one that was very temperamental. They all had to be individually adjusted. And you can see how the circuits were toppled on top of each other. Boards were put in. As we built this thing and discovered things, everything was sort of on top of each other. So it was truly a prototype. Now, I want to share with you the playback system because I think it's important. There were no personal computers, but there were tabletop development systems. Microprocessor chips were just coming out, and there were development systems that engineers could use to develop products using microprocessor chips. And so there was one that became available from Motorola. It was called the Exerciser system, and the great thing about it was it used a new bus architecture, which was a publicly verifiable bus that I could build boards for that would fit in this thing. And so that's what we used. And we had to build custom circuitry boards that would fit in this thing and allow us to capture the image and then to display it. And also, we had to do actual image manipulation. I had never done this before, but I only had 100 lines of information. Remember the chip? And if you have a television set, you know that you display about 490 of the lines for NTSC. And so I had to do actual interpolation or duplication of lines inside the frame store. We had never done that before. We did that with assembly language programming. You software people know how delightful that is. And so we actually did that on this program as well. And then we output to a standard television set. It was the only device I knew of that would display a continuous tone signal. This was only a black and white camera, by the way. So here's a picture of how it looked. And you can see that the microprocessor system sitting in the center. On this side over here, you can see my photo album right here, the playback unit, that, and then the television set with a picture being displayed. These pictures are from the 1976 technical report. They are the only demonstrations I have of how the camera actually performed that were documented. In order to do any kind of imaging device, no matter how crude and weird it was at the time, you had to do it in Kodak, since they're very sensitive about images, as a standard way to do it. So I had to get a standard test target. This was the boy dog test target that we used for black and white imaging systems. And I backlit it with a crude fluorescent light at the time. And then I came in with a prototype and I took a picture with it. And then I took the cassette out, put it into the playback unit. The playback unit displayed it on the television set. Then I moved the television set next to that. And then, because I was not allowed to take pictures inside the Eastman Kodak company, that was a corporate rule, I had to hire a Kodak photographer with a film camera to come up and take a picture of this. Now, I don't know how that strikes you, but I always thought it was a little weird. But that's how we had to do it. And I want to show you here, just want to take a second to show you, because we're going to talk about the reaction to this next. And I want you to see exactly up close and personal what this thing looked like. This had all of the negative aspects of a digital image, or early digital image, that they could have. We had it all. We had contouring, that is the lack of bit depth. You could see maybe the stair stepping up on the right-hand side of the corner where it goes black and then jumps to another color, to another brightness, and to another brightness. That's because it didn't have enough bit depth. It had no resolution. There are whiskers on that dog, believe it or not. You could not find them. The interpolation we used was very crude, and so you can see where the dog is over here. You can see the stair stepping, and that's because we weren't interpolating correctly. And then if you look throughout the image, you can see all of these white spots. Those are full response non-uniformity. There were defects. This was the best device that anybody could make at the time, but they showed up throughout the image arbitrarily. So when I talk about the reaction that people had to this, this is kind of what they were looking at. And they were comparing it to conventional film at the time, even the lower end of conventional film, 110 film, for example. That was the consumer small camera at the time. So this is what they were seeing. So quick on the timetable, we started in '74, captured the first image in December of 1975. I like to tell the story about that because it shows you how these things go. We could never see any image for the entire duration we were building this, both camera and playback unit. There was no way to see anything. We saw everything by voltage measurements and oscilloscope traces. That was it. That's how we knew it was working. Finally, the whole thing got together. I looked at Jim and I said we should take a picture of something, but our lab was pretty ugly. So I walked down the hallway. I found a young lab technician. She was sitting at a teletype. Her name was Joy Marshall, and I asked her if I could take a head and shoulders shot of her, which she agreed because she knew we were the weird guys at the end of the hall. And she was comfortable with us there. And so I did. I took the shot, and you could tell the camera was working because the tape started to turn. So I walked back to the lab, and Jim and I went back there. We popped the tape out, put it into the playback unit, and then up popped an image. And what you could see was, you could see her hair, you could see the background, which was light, and then her face was complete static, completely unrecognizable. But Jim and I were so happy because we knew of 1,000 reasons why you might not see anything at all. The fact that we actually saw the outline of an image that we just took was remarkable. And we said, so much is working, so much was working. Well, Joy had followed us into the lab, and she was less impressed with the image. And she just said, she looked at us and said, needs work, turned around and walked out. True story. True story. I couldn't make that up. When I designed the playback unit, I had reversed the order of the bits somehow in my mind. I hadn't thought about it. So if you know how digital works, you have a number of bits in sequence, and that determines the value. And so if it was all zeros or all ones, the order didn't matter. So if it was black or white, it didn't matter. That's why I could see the background light, the hair was dark. But when I got to the continuous tone of the face, they were all reversed. So it took us about an hour to figure out what it was. And then we reversed the thing, and up popped that first picture, and that was quite a thrill. We wrote the technical report. It was issued in January of 1977. We filed and received the first patent for a digital camera in 1978. And then we began our demonstrations inside the corporation of this system. And I'd like to share with you exactly what we did. First of all, this was only going to be described and talked about inside the company. So they were only internal audiences. And what they did was, and you've all been in organizations, so you know how this works. You go to your boss and you convince him that this is worth showing to somebody. And then he gets comfortable with it and he invites his boss, and then his bosses bring their friends. And then when they get comfortable, they invite their bosses, and so that's how it went throughout 1976. But all of the demonstrations took place in a conference room. It was a very small conference room, typical long table down the middle. And people would go in there, and we would move the playback unit to the back of that conference room. And then I would come in, and I would take pictures of people in the meeting room. What I would do is I would walk in with the camera. I would then walk to the person who was sitting right at the front of the table on the right, and I would take a head and shoulder shot of them. And then I would start to describe what this thing was, to cleverly hide the 23 seconds I needed before I could take the next picture. You learn about public relations, you really do. Then I would take a picture of the person sitting on the left, same head and shoulder shot. And then I would go and hand the cassette back to Jim. He would put it in, and then up would pop the picture. And I must tell you, I don't think I've ever finished my demonstration or presentation, because the conversation started right away. And there were lots of questions and lots of discussions. And let me share with you some of the reactions. First of all, this went up the management chain up to a certain level, pretty high actually. It's the head of all of the apparatus division, which was the guy who made all the equipment for Eastman Kodak throughout the entire world. And he saw it, but they elected not to show it to the corporate officers. And I found out at the time that the corporate officer had heard about it, and even asked about it, but they were told by the higher-ups that they didn't want to show it to them. It really wasn't ready for prime time. Now, I was a little annoyed at the time, but think about it. We were taking pictures without film and showing them without printing inside of Eastman Kodak Company in 1976. So if you were a manager talking to the corporate officers, how would you explain it? Right? I mean, there was a lot of questions, and I think we all get uncomfortable in just presenting a concept without having lots of answers, But this was kind of a new idea, and so there really weren't a lot of answers, but there were lots of questions. I would say generally the reaction of this, it was too far out there for serious consideration. And what I mean by that is not only was the camera not using film, but there was nothing in here to use any of the existing photo chain, the photo infrastructure that existed so commonly throughout the world at the time. There was no photo finishing. There was no delivering. There was none of the things that we were used to thinking about really pertained. So this was really far out there, and they really couldn't grasp all of this. And I must admit, I couldn't either. I really didn't have answers to most of the questions they asked. They were very, very sure that people would never want to watch their pictures on television set. And I thought that was strange even at the time, but that was pretty strongly held conviction that people really wanted prints They loved prints, this is what they valued, and they didn't value looking at a television set. In spite of the slide business that we had, which basically projected images onto a surface as well, but they were quite sure about that. And then there were lots of questions, how are you going to store the images? What's a photo album going to look like? This electronic photo album going to look like? And then how are you going to get the film-like quality? I mean, the quality of this thing was terrible. You saw the close-up. And then how long is it going to take for this thing to be realistic? And I didn't really have answers to a lot of these questions, to be honest with you. But I do want to share with you, you have to take a look at these questions in the context of the times. This was 1976, okay? Now, when you have innovation, you have to think about the innovation you have and then the technology you use to demonstrate the innovation. They're separate, and don't confuse them. I use digital. This is a completely digital approach. Now, today, you would think, well, of course, digital, right? Everything's digital. You can't sell a product that doesn't have digital in its title. You can't. But back then, digital had a totally different connotation. It was unreliable. It was esoteric. It was exotic. It was expensive. It was complicated. It did not help me that this was digital. Digital just made it seem more distant. Okay, so when you innovators out there, when you think about, try to keep the technology used to demonstrate it and your idea in separate camps in your brain, because it can sometimes hurt you. And then I also want to, these things that are going up here now, these are all things, think about them. If you didn't have these things up here now, the utility of that digital camera that's in your pocket or purse right now would have a marginal utility. The entire world changed and developments took place that I wasn't really thinking about at the time. But without them, digital cameras wouldn't nearly be as useful as they are. And so we weren't really thinking about these things in 1976. But in view of that, the question that I was asked is, when will this impact consumer photography? I was asked every single meeting, and every single time I said, I have no idea. Because I didn't. It's funny, when you do these things, you work so hard at the technical tricks necessary to make something work, so you think everybody's going to ask you about how you got that to work, or what technical thing did you do there, and they didn't ask any of that stuff. They just wanted to know when this thing was going to be real. And so when you get asked a question enough times, you say, okay, I have to come up with an answer. I had a digital approach, completely digital. So therefore, I thought Moore's law might be able to help me. Moore's law was that commonly used expression that basically defined how fast digital technology would advance. It was postulated early in the 70s, and it maintained its integrity throughout the 80s and into the 90s. And I think, so I used that, and I said, I called up the research labs, and I said, okay, how many pixels would I need to have a reasonable consumer image? I said, don't get carried away on me now. I said, just 110 film quality, that kind of thing. And they said, oh, that's easy. 1 million pixels. 2 million if you want color. All right, I had 10,000. And they were telling me 2 million. So 200 times, and I used Moore's law to project, not knowing if Moore's law applied at all to CCDs, which is fundamentally a transducer. But I was desperate. So I came up with the answer between 15 and 20 years. So that's what I told them. And as a point of interest, our first consumer camera was launched 18 years later. And that was purely an accident, because I had no idea. I overestimated some things and underestimated other things. And I must tell you, I was purely a lucky guess. But it was a long time, basically, when I was standing in front of them in '76. Clearly, the imagers needed to be worked on. Kodak very aggressively went after imagers. Kodak, even to this day, is still the world's leader in CCD imaging. They make enormous arrays right now. We knew that the key to this was going to be in digital solid-state imagers, and so we went up to a very aggressive pathway to make imaging. So Kodak was working on that. There was another aspect of this thing called the digital storage. You know that digital cassette I used? So I guess I didn't make my new moving mechanical parts goal. But I knew that what I really wanted to do was to have solid-state memory, but a solid-state memory that really didn't exist at the time, which was something that would store a digital series of words, high density, low cost, with no battery required. And they didn't exist. The EA-ROM started to come out in the 80s, so the technology started to get worked on. I called it digital film. Again, you have to be careful what you call things. Here's, for you innovators out there, You have to worry about public relations. Be careful of the words you use. When I entitled those meetings I had people come to, you know what I called it? I called it filmless photography. Bad choice. I mean, given the audience, you know. So you have to pay attention to the words you use. And I use digital film a lot because it really got across the idea of what we were looking for. But, you know, created some negative vibes. But anyway, that was something that was being worked on, and we worked aggressively on that. We never made these devices, but we worked with people that did, and that started to become available in the late 80s, early 90s. And then digital circuitry in general. This whole idea was digital, but there was a whole bunch of stuff, digital memory for sure, had to be dealt with. Then the speed, the cost, the power of these things, how much image processing can you do, all of that stuff was really outside of the domain of the technology of expertise of Eastman Kodak Company. We didn't make these things. But we knew that the world was working on these things for all different types of applications. So we knew that the development curve was going to happen, and we had to follow that. So those were the three main areas that I think received a lot of work over the next several decades. That's what we worked on. Some we worked intensely on at Kodak, the imagers. Some we worked with vendors on, like the digital film. And some we went along with the rest of the world in terms of riding the development curve. Now I want to share with you a little bit about what happened next, because I think this is interesting, and give you some idea of how these things go ahead. About at the same time, there was a researcher named Bryce Beyer. He was working in our research laboratory. He's an image scientist. And he solved the problem of how do you get a two-dimensional matrix like a CCD and get color out of it. And he patented that in 1976. And he solved the problem of how you get color out of a CCD before we even had digital cameras, because he was looking at it from a human perceptual point of view. If you ever get a chance to read that patent, it's more about image processing and how the human eye and brain works with color images than anything to do with digital cameras. I did meet Bryce a few times. He was working on something I thought was really fantastic, because color really scared me back then. But he would solve that problem. And if you have a digital camera today, no matter what make or model, no matter what expense, you have a Bayer array in that camera. That was a fundamental technology development that was done at Kodak, and that's the patent. In the 80s, I don't know if any of you remember a still video floppy. This was a wonderful development in my mind for two reasons. One, remember what this was a small 2-inch disc. It was a magnetic disc. And it was developed by Sony, but it was pushed by Canon as well. And it rotated at 60 hertz. And with a magnetic head, you'd go and quickly write one field or two fields of a NTSC signal on there. And that would be the still image. And it would rotate at 60 hertz going back in a player, and it would be put on a television screen. So there was no digital part of it. It looked digital because it had a little magnetic disc, but it really wasn't digital. It was an analog system that used a modified form of NTSC encoding. And I liked it for the two reasons. One was it was being pushed by major competitors that were very different from Eastman Kodak's former competitors. We had competition with AGFA and Fuji, but now we were potentially looking at Sony and Canon. Big, important companies that had technology expertise we didn't have in an area we didn't have, but they were coming into our business. And so as much as we were talking in the late 70s about this, you really weren't getting much traction. But when an outside threat starts to appear, then management starts to think a little bit more seriously about this, and they did, and they started working on it. And we had a very active program in still video floppy going forward in the 80s. And the second reason I liked it was because I knew it was never going to work. It fundamentally had a flaw. If you looked at it very carefully, an NTSC signal, or this was encoded with a modified form of it, had artifacts that you would never accept in a still photograph. It was useful for displaying on a TV screen, but if you ever wanted to make a print of it, for example, it would have artifacts you would never accept. And I think you have to recognize that if you have a displacement technology, no matter how cool you think it is, it will not displace the existing technology unless it meets every single critical attribute of the existing technology and exceed it in at least one. Don't ask the public to accept something less just because you're giving them something cool in another area. That won't work. And so this fundamentally had some flaws from a photographic image quality point of view that they couldn't get around. And so I was happy to see it because they were going to work on it for another 5 years, and then it was going to be a dead end. And we knew that photography, if it was going to go electronic, was going to revolve around the computer rather than a television set. Now, the computer was evolving very rapidly in the 80s, but we knew that's where it was going to have to be because we could not deal with the restrictions of the encoding systems that were presently used for moving video. So we worked very hard and we introduced the very first megapixel sensor. It was a 1.3 megapixel sensor with a bioarray on it in 1986. So we showed that at a show. And we did that not because we wanted to tell people we were working on it, but we wanted to start to give people some confidence that Kodak was really looking at this. Sony was introducing at the same show a big imager, but wasn't nearly as big as this and didn't deal with color. And when we showed this, then Sony shut down their exhibit because we really outclassed them here. But we were doing this all underground. We really weren't talking to many people about it, but this is the first time we introduced it. But we knew it had to be better than NTSC. We knew it had to be better than a Vidicon kind of a thing. And so that's why we started making these big imagers. And then the real issue was, what do you do with this? The bigger these imagers get, the more memory you need. You're fighting a losing battle here because 1.3 megapixels really wasn't enough. We knew that. It might get us in the ballpark, but we knew it had to go way beyond that. And so we knew image compression had to take place. And so I want to tell you a little bit story about an image compression device that we built as an experiment. I wanted to try to get image compression from the laboratory into a product. And so I'm going to tell you about a product that you've never heard of, but you've probably seen the results of. It was an image transceiver. We introduced it in 1987. And what it was just a box about the size of a VCR. And what it was just a simple box that would capture an image, digitize it, and then we would apply an image compression algorithm that we were working on that would squish down the number of bits, maybe remove about 80 to 90% of the bits you've captured, to reduce it down to the essential number of elements of bits, and then send it over a telephone line in under a minute, and then we would reconstruct it using an identical device at the other end of the line. That was the idea. We proposed this because we thought that this was going to be very critical, and I wanted to get this, all these image compression algorithms were being done in the research laboratories, and it was really wonderful, but big computers, really smart people, and I said, no, it's got to be somebody dumb using it, and it's got to work really well, and we've got to really get this done. So I went to one of the world's leading experts that worked at Kodak. His name was Dr. Majid Rabbani. And I asked him, I said, what compression algorithm will the world go to? And he said, oh, there was about 24 different competing algorithms at the time to try to get to what we presently call the JPEG standard today. And everybody was arguing about which approach was better. It was sort of like religion, you know. People just argue with these things, and you never know who the right answer was. When I went to Majid, he said, that's easy. It's going to be discrete cosine transform. The world will get there sooner or later, but that's the one you have to do. So I said, great, a firm answer. So then I went and looked and see what a discrete cosine transform requires. I went back to him. I said, Majid, this is like really hard. You got anything else? A lot of calculations. And he said, no, he says, that's your problem. He said, that's the one that you're going to have to do in order to make it work. So we did some pretty innovative engineering on this. Here's the block diagram of the device. You can see the video camera would take the frame store, the DC decompression, very complex mathematical construct, squeeze the bits to the essential number, send it over a telephone line and reconstruct it. Now what we did there was Kodak was working on this, and part of this is how you throw away these bits, and we based it on the human visual response. And Kodak knew so much about how pictures are acceptable to people. We knew more about still photography than anybody in the world. We knew what people liked, what they didn't like. We knew about different parts of the world and what they would accept and what they wouldn't accept. And we knew some of the artifacts that might be introduced by doing this. I mean, think about it. You're throwing away 90% of the bits you just captured. Didn't make people feel too comfortable in the image science area. Okay? But we had to do this in order to keep it economically viable. And so we built this device and we put it out on the market. I didn't really care if it sold. I can tell you that now. Back then I had to say, no, this is a really great product. Because you know, it really didn't matter. I really just wanted to get this very complex thing out of the lab into a product. And that's what we did. And I must tell you, there's some unexpected attention we got with this. And this is where you were exposed to this product, you just don't know it, because we never told anybody about it. It turned out that CBS News had bought 2 of these devices. I didn't even know this. And then in 1989, the Tiananmen Square issue had come up, and there was, they had shut down all of the ways to get pictures out of the country. They were trying to shut down all communications, and they did. But they didn't know about this. And then CBS News used this to get those pictures out that you might have remembered from Tiananmen Square. They used this device. And they got so excited about this, they wanted to do a television story about it, a news story. And so they called up our management. And they didn't want to do a news story. Because, think about it, now you're at this tension point. This device, in a sense, takes away the professional photographer using film and puts him at a disadvantage. And so there was this tension between the new technology and the old technology. And this was a real marketplace issue. You were going to go on television and talk about this thing. And so they came to a compromise. And they said, okay, you can do the story. This was we had a lot of innovative people in Kodak, even in management now, that were pushing this. And they said, let's do this. Don't mention Kodak, but show it on there and talk about the story, okay? And so don't mention the name of the product, don't mention Kodak, but you can tell the story. And so that's what they did. So I'm going to show you the 2-minute video that was broadcast in 1989 by CBS News. And you'll notice how the picture comes up. It comes up on the screen. You'll notice the Kodak name on there. But you'll also see how the picture comes up. It's very odd. It comes up blocky. Those are those DCT blocks coming up. And they come across the screen. And you can see how this innovation impacted their business, made a big difference. And yet we were afraid to talk about it. Let me show this to you.
On the streets of Beijing. Now, the sights we have seen so far have been gripping, and it has taken a marvel of technology to get them out of the country. We have that story from Channel 2's Jane Velez-Mitchell.
They've roughed up reporters, but the Chinese government still hasn't been able to stop it. The flow of compelling images, massacres, monumental courage, pictures that have galvanized world opinion. The horror stories have kept seeping out, even after Chinese officials confronted CBS News anchorman Dan Rather and made him shut down the satellite that was used to feed videotape of the historic democracy movement. After the Chinese officials shut down the satellite, they may have thought that they had stopped the flow of videotape from China to the rest of the world. Normally, that would have been true. Normally, you would have had to have physically transported the videotape to another feed point in Tokyo or Hong Kong and sent it from there. But in this case, thanks to new technology that CBS used for the very first time during this crisis, the network was still able to get dramatic pictures directly out from China to New York and then to the rest of the world. It's called a transceiver or pixelator. Folks here at CBS Network call it a magic box, a machine that takes moving pictures, captures a single frame, then breaks that frame down into computer information or digits, and through an ordinary phone line, sends it to a similar magic box in New York. It then takes the information and turns it back into a single picture. Reporters in Beijing then use a cellular phone to speak live on television from Tiananmen Square over the pictures.
You hear that gunfire?
Fire, we do hear it.
Okay, we've got to get out of here.
Commandeering the crisis coverage for CBS, Lane Bernardos, director of special events for CBS News. He says that single piece of equipment, the magic box, has changed the face of its news coverage.
This is a godsend. We could not have done what we've done over the last, say, 36, 48, 72 hours without this kind of device.
To the Chinese, it's been a lifeline to the world.
We took in some still photographs of crowds cheering our TV crews. They're so happy to see us, even though it's forbidden now officially. The people are saying, they were saying to our crews, get our story out.
While the Chinese could confiscate the magic box in Beijing, fans of the new technology feel no regime can stop the flow of technological advance and predict the future will make it increasingly difficult to violate human rights in an ever-shrinking global village. Jane Velez-Mitchell, Channel 2 News.
Okay, so that's under the title, You Just Never Know. We had no idea that was going on. The reason we wanted to do this device was because, think about what this was. It was a frame store, that is something that would digitally capture one frame of information, a picture. Then we would do this DCT compression and we send it over a modem. And what you connected to that was a video camera. The reason we wanted to do this was because if you got rid of the video camera and you replaced it with a CCD, if you replaced that modem with something called a memory card, if you ran it off of batteries and you shrunk it down and you put a lens in front of it, what do you call it, right? This is what we wanted to do. Wanted to put image compression, real time, inside a portable camera, and then I think you've gotten rid of the last major problem with digital photography. So this enabling product drove this, so we had to work through all the issues with doing that image compression in a real time using an actual chip, a TI DSP chip at the time. And once we had that, and we knew we could get good images, then what we did was, and this time I had the good sense of working with someone who really knew how to design cameras. His name was Bob Hills, and he was an old Scotsman and had forgotten more about cameras than I'll ever know. He designed more cameras than anybody I know. And he worked with me, and he said to me, Sasson, he said, if you want to build this funny digital camera of yours, he says, it's going to look like a camera. It's going to act like a camera, and we're not going to pretend it's not a camera. And so I want to show you a camera you've never seen. It was an experimental camera that was built. It looked like this. We worked with Chinon. We had a relationship with Chinon at that time. I'll show you the specifications of this camera. It used memory cards. It had a 1.3 megapixel sensor in it. It had DCT compression in it. It was fully operational in 1989. We built about 6 of these. They were hand-built. They were never manufactured. They were never advertised. We never talked about them. But we used them internally to see if anybody would be interested in marketing these things. And the answer we got back was, from the channels was, oh, sure we would, but if it comes at the expense of one film camera, we won't do it. And so we started to enter this period where now the technical problems, as far as I was concerned, were really kind of solved, or you could see the solution. Okay, the elements were in place. I mean, this camera worked. I would say this was the precursor to most modern DSLRs. I mean, this captured pictures rapid sequence. The fundamental IP that is in this camera is licensed by every camera manufacturer in the world today. The IP, the architecture that basically defined how you did this, how you captured these images in burst mode, how you did image compression on them, how you stored them on memory cards. See the slot here? That's where the memory card went, right there. So it fundamentally defined it, and then the IP that came out of that is licensed by every camera manufacturer today. Now, at this point, they decided they really didn't want to put this camera out. So this camera never went anywhere. There's only one of these cameras that's still in existence, but it does exist. And represented, I think, sort of the end point of the fundamental technology challenges associated with digital photography. Now I want to share with you what some of the cameras we did commercialize and how they were accepted. One of the first cameras it went into the professional market. You always have to find a market where they will accept some shortcomings in order to get some new feature that really earns them money. And professionals were very interested in this because digital cameras allowed you to, at first, transmit information over a telephone line and get it back to your publisher so that that picture can go on the front page the very next day. That was money. That was worth it to them. They would put up with all the inconvenience and the cost of these very early cameras. The very first one was called the Hawkeye Imaging Accessory. That was its official name. They were not allowed to call it a camera. And it worked with a Nikon body, and then it was tethered to that box that you see underneath there. There was only a handful built, and one of those was one of the first digital cameras that went into outer space in a 1991 space shuttle mission. Again, not many people talked about that, but that's what happened with that one. The very next one in 1992 came out, and it had a big electronics pack as part of it. And you could actually had a black and white screen on there, so you could actually preview the image and transmit it. Okay, $25,000. We sold about 1,000 of them to those photographers where it was worth it for them to do this. Okay, and then about a year later, we introduced the first fully contained professional camera. This had about a 1.5 megapixel, I think. And it was all self-contained, again using Nikon bodies. Why Nikon bodies? Well, professional photographers like Nikon. Second of all, we didn't want to rebuild the bodies, and we could figure out what was in there. Now the problem with it is, and you'll notice here, that this is the first camera that we produced that had Kodak on it. Now Jim McGarvey, the chief engineer on this project, told me the story behind it. And that was, we introduced these at shows, and people always seemed to think that Nikon had something to do with it. Nikon didn't even know we were working with their cameras. We bought the cameras retail and built them. And, but they thought, our designers started getting really insulted, right? So they made sure that Kodak appeared in big letters, bigger than Nikon, on these cameras, just because the designers were sick and tired of answering that question at the shows. First consumer camera came out as called the Apple QuickTake. Apple Computer marketed it. We designed and built it. The reason we did it is Apple came to us and asked if we could build this. We said yes, but we had no marketing channels to do this. I think we also had some reluctance to go into this. We didn't know really how to market it to consumers, this digital camera. This was quite a device. It was 640 by 480 capture. It captured 8 images. It used SCSI bus to transport it back to your Apple computer. And so it was really novel, and it was the first sub $1,000 consumer camera available, and it was color. Tom Kelly, chief designer of this camera, told me the story that the reason it looks like a binocular, because it had to look like that. It couldn't look like a conventional camera. We had a real problem. Our people had a real problem with having it look like a real camera. So they had to make it look that way to differentiate it. But it was sold through the Apple channels and was quite a famous camera at the time, because Apple Computer was wise enough to see that digital photography could be a great part of the future of computing, desktop computing. We introduced the DC-40, looks remarkably similar to that. A year later, in 1995, this was a little bigger, I think it was 756 by 512 or something, but very similar to that. And then I think the consumer started to move. And I think in 1997, the first million-pixel consumer camera was introduced. And then every year since 1997, I believe, the number of pixels has increased by 1 million pixels a year for consumer cameras. So it's been a dramatic increase in resolution, quality, cost, obviously, over the last decade and a half. And so that's how digital photography then started to take off from that point. Now, I want to, all talk should end with a story, and I want to tell you a story. I had the privilege of going overseas to China to talk about the history of digital photography. They're very interested in this, and since it was after 2001, they asked me to go out and talk about this, and so I did. And I was in an interview with the Chinese press, and what they do is you go into a room and you sit at the table, and a whole bunch of reporters come in and they ask you questions, and then they get up, leave, and another bunch come in. And it was in between one of those breaks I had this revelation. I had brought with me one of the cassettes that I used to capture some of the very first digital images, and was standing up on a table just like you see there. And next to it was a digital camera. It was called the EasyShare 1. That's what we were launching at the time. It was a really pretty interesting camera. It was about 6 megapixels resolution. This is about in 2005. It had Wi-Fi connectivity, one of the first Wi-Fi cameras ever. It had a great display. It had 256 megabytes of internal memory. So it was quite a device, right? And they were sitting there like that, and I had the realization they're about the same size. And I had the thought. There's an old expression about engineers that they always overestimate what they can do in 5 years and underestimate what they can do in 20. And I think I want to add to that, they can't imagine what they can do in 30 years. Thank you very much. Thank you. Thank you very much. Thank you.
If you have questions, I'll come by with a microphone. Just raise your hand. Oh, start right here.
When did the charge-coupled device get introduced in astronomy? Because that's been a huge breakthrough in astronomy. When did that happen?
Yeah, I learned a lot more about that. At the time, that was one of the first uses for the earliest CCDs was astronomy, because they could cool those devices down inside of the focal plane of these telescopes, and so get very good signal-to-noise ratio. I had a very good opportunity to meet Margaret Geller from the Harvard Smithsonian Observatory. And I got a tour of there, and I met some of the people who worked with very first CCDs. In fact, they worked with the very first CCDs that I worked with. And over a beer, I commiserated with how horrible they were. And they really enjoyed talking to me because they never met anybody who could really appreciate the pain that they went through making these things. So it was really in I would say, the late 70s, they started appearing. The resolution wasn't that great in an individual device, but they used table steppers to move them around to get full resolution. So they could control the environment They had plenty of money to spend on it, and there was no, and they could do some mechanical movement of it to get it. So it was in the early, I would say the late 70s, early 80s, they really started making inroads, and they were the first people to really start to use these things.
Steve, back here in the middle of the room, back here.
You were describing the first chip that you were doing, you were using for the first prototype.
Yes.
And you kind of described it as if it was a manufactured device.
Yes.
What was the purpose of that chip before it had the purpose?
Well, honestly, I think CCDs, when they first came out, were just line arrays. That's how they first came out. They were just sort of, there was a term they used called bucket brigades. That was using a different technology, but it was a way to store charge for a period of time. And you could use that for some things in electronics, in analog electronics. That was helpful. You could use delays, like line delays. In a television set, it's helpful to have a line delay sometimes to combine color and stuff. Line delays being delays of a signal, an analog waveform for maybe 60, 70 microseconds, you know. So they were first used for those kinds of applications. They came out with this area array, which I think was fundamentally their first attempt to try to build a device, you know, build it and they will come. And I think they were using it for metrology purposes, astronomical purposes perhaps. So there was a lot of, but there was no application notes that say, hey, this is what you could do with it. They were happy that anything worked, I'm convinced, because they were very, very, very difficult devices to work with. It was Fairchild that was doing it, and also RCA came out with a device. They were all trying to get to replace a Vidicon tube. That's what their drive was. That was the ultimate goal. But they weren't trying to suggest that the intermediate goals, which were these reduced resolution versions, were satisfactory for that purpose. It was the technological step they were making, and they were putting them out and seeing what happened. That's my opinion.
Steve, back here on your left.
Yeah.
In the marketing world, we know the first company in usually has a really long-term, long-standing advantage. Was it Canon or Sony that was the first in? And do they hold the main market share now? And looking back on it, should Eastman Kodak have been the first in?
Yeah, this is the question. This is going to be a really long answer, but let me just try to shorten it up. Kodak knew about this technology and was leading the technology. I'm not exaggerating when I tell you that the intellectual property underpinnings of most of these cameras came from Kodak. We had a problem with our existing business versus this new business. The existing business was a very profitable business. I hope I don't shock anybody, letting you know that making film was really, really, really profitable. Okay. Now, when you come along with a new technology, as cool as it may be, and the new features that it offers, there's always the little problem. A marketing guy knows the business case. You have to have a business case. And there was really no business case that could even come close to the business case associated with film. The barrier to entry wasn't as high. Clearly, the return wasn't as high. The technologies we had were developed by other people, so we didn't own it. And then this fundamental problem we had with photography. In photography, Kodak understood the value of a good image. Nobody ever questioned the quality of these images. And the reason we had the quality of the images is because we made the film and the dyes. We controlled a lot of the photo finishing, right? So we really controlled this whole chain so we could maintain the image quality that people expected. All of a sudden, the digital chain comes along. To capture an image and make a print on your inkjet printer in the late 90s was a horrible experience. We called it the chain of pain. That's what we called it. And the reason was because all of these things were made by different manufacturer, right? I mean, the camera was made by somebody, and then, you know, they downloaded the image, and the software was written by somebody else on a computer made by somebody else. It was sent to a printer, it was made by somebody else. And nobody had any control over this chain. So fundamentally, what we held dear was very good image quality at a reasonable price, very reliably maintained. It was a really hard sell to move away from that, which is what we fundamentally had to do. So I don't want to turn this into a big treatise on this, but it's a long story. But fundamentally, there were business case problems. Okay, there were technology problems. There were cultural problems. Okay, Kodak is still a major player in digital photography. Depending upon what year it is, we're number one or number two in consumer cameras in the world. I don't know if we are like this year, but like a few years ago we were. It's not a terribly profitable business when it comes to consumer cameras. I don't think I'm giving away any secrets there. Nobody makes much money off of these cameras. The people who make money off them are, Nikons and Canons when they sell you those great lenses. You buy the body and then you find out how much the lenses cost. That's the business model, So we are a major player in there, but I would say the fundamental business model for imaging has substantially changed, and that's the main reason.
Steve, back here on your right.
In the excerpt of the project proposal you put up there, you said something about recording sound. Did one of your prototypes ever have a microphone?
No, I didn't dare do that. The concept was I just took a look at the digital aspect of this, and I said, well, what could I do? If I could digitize a video waveform, I certainly could digitize sound. I didn't think that was a technical leap as such. I didn't have any way to store it. I still had the storage problems, okay, and the playback problems would have been enormous, but I could have done that. Nobody was really asking for that. And again, it goes back to the innovation part of it. If you have a disruptive innovation, you try to keep the idea as simple and focused on the fundamental disruption and not go after the auxiliary or the things that will try to make it interesting. Sometimes inventors are funny people. They really are. If people don't get it the first time, they usually tell it to them again louder this time, kind of thing. And then they start adding on all these, and it can do this, and it can do that, in a desperate attempt to keep people interested in their idea, right? But I think what you have to do is fundamentally address the core of your idea, and then address the shortcomings honestly, and then keep working on them, okay? So sound was a secondary thing. I also talked about taking infrared images. CCDs are very sensitive in the infrared. The MTF of the device goes down, but you can capture a lot more information. They're much sensitive in the infrared. I thought that was really cool, taking infrared images, nobody's interested in that. But I thought it was cool. Sound, infrared imaging, that kind of thing. Storing lots of images on the cassette tape, as I mentioned before. Those are all secondary things. And I talked about them briefly, but I didn't want that to be the center of the discussion because it just made the concept seem more distant. And so I tried to keep it simple there, but I did mention it in that brief paragraph.
Steve, up here on your left.
You mentioned on that hand-built, I think it was the D5000, that a handful were made, one exists. Where is that, and what happened to the others?
Okay, the D5000, the ECAM, we called it ECAM, that's how I remember it. Stands for electronic camera. Bob Hills insisted on that. He was a Scotsman, he was real stubborn. I had a great time working with him. We built these hand cameras. There's one camera left. We have it in our little museum. Actually, it turns out to be useful in litigation, actually patent litigation. You'd be surprised how many people think they invented the digital camera. And they're all there. You name an electronics company, and they usually come in. And if we're involved in litigation or a licensing issue with them, very often I'm called to testify and to say, well, let me tell you when the first digital camera was taken, picture was taken, and I have the original camera. And then we tell about some of the other historical cameras, and we have those, and we use those sometimes for that. What I hope will happen is they go to a museum. Well, we have a very famous camera museum in Rochester, the Eastman House International Museum of Photography. And hopefully those cameras will end up there, but they're in safekeeping at Kodak office right now. Why only one left after 6? Those 6 were used for subsequent developments. They were so far along that they provided a great platform for looking at different aspects, different compression algorithms. So they were used as tools, and they gradually broke away. And another thing I want to tell you is, as much as we stand here today, and it's really great to look back on it, when you're actually there at the time, these things don't seem that great to people. They don't. The historical nature of it is sort of lost on you. The only reason that I have the original camera that still exists is because I kept it because I thought it was just cool. It was a personal thing that I kept. I kept it, and I told this story earlier, I kept it in my office, and I moved offices, I put it in file cabinets, or I put it in somewhere else. And I lost it several times over the last several decades. I would move an office, I'd forget that I put it in this file cabinet, and then a year or two later, somebody come walking in with this thing, is this yours? And I said, yeah. So if you ever do see this camera in a museum, if you turn around on the back of it, there's a little sticker that said, please return to Steve Sasson. I had to put that on in about 1981 or 82 because I kept losing the damn thing. But the fact is that you don't really think about the historical nature of it. I just kept that camera because it was my personal, it was just a great experience for me, and I kept it. I called it my baby because it made me cry a lot. You know? But that other camera, I think, was kept. We didn't even know. We had gone through a major litigation, and we didn't even know it still existed. And then one of the old guys who worked on it had it in his basement or something and brought it in, so we have it. So we still have one of those, yeah. That's where I got that picture, by the way.
Steve, right here.
Yeah.
I think I know what your answer will be on this because you partially answered it, but I'm wondering why Kodak abandoned the professional market in the last decade. I bought a DCS 330 in 1998, which was 3 megapixel, excellent quality.
Yep.
Later on, I moved up to an SLRN, which I still have, and it still works great. Kodak stopped supporting it in 2008.
Yeah.
And I have other cameras too, but it seems like every one I buy is $5,000. You know, every body.
Yeah, but you buy ones that your lenses fit, right?
Right, exactly.
Yeah, okay.
Yeah, I was a Kodak, I was a Nikon
Right,
man, so
right.
that's why I went to the 330 in the first place.
Exiting the professional business was a hard decision for us. I knew a lot of the guys that worked in that area. They got up to 14 megapixel cameras, I think, before the 14N, I think was the last one they put out. And, but they had to get out of it because they were losing money. The money is in the peripherals, the money is in the lenses, the money is in the accessories. These cameras, as much as they cost a lot of money, they cost a lot of money to produce. And there's not that many of them. There's no volume there. I mean, so it was not economical for us to continue, even though it provided a tremendous platform for technology development that found its way into consumer cameras. But around that time when they left that business, which was, I think they left the business earlier than 2008.
They supported the camera until 2008.
Yeah, so I think they...
I remember getting a letter in 2006 saying, bad news, we're going out of the professional market. Good news, we're going to support your camera for 2 more years.
Yeah. Well, that's about the average life of a professional camera anyway, it seems like.
Still works.
Well, that's good to hear. I'll tell the guys. I know some guys. No, there's a lot of dedication to the art of that, and it provided an enormous technology platform for us. But it was uneconomical to continue the business. But we continued on with the consumer arm of it because it was an enabling technology to sell printers and things like that. But the professionals didn't come that way, and we didn't sell any of the accessories, so it was sort of a loser for a while. So that's the 30-second answer to that one.
Steve, up here on your left. And due to the time, I know there are a couple hands up, but we have time for just one more question.
Steve, I had the privilege of taking a DCS 460 to Antarctica in about 1995-96, and it had a little microphone on the back that I could record caption information, which you could then read back or play back later on. And I'd like to thank you for all your great work in producing this camera and being a visionary in this area. But my question is more about the fact that now we have the complete democratization of photography, mostly through cell phone cameras. And is that something that you had predicted or could have thought that was going to happen? And the follow-up is, where will it all end? Where is it going?
The answer is I didn't know, and the second answer is I don't know. Yeah, you know, I didn't predict cell phones, let alone cell phone cameras. I had a chance to meet with Cooper, who invented the cell phone, and I had a chance to meet with him in London a couple of years ago, and we had a chat about this, and you know, the two of us standing on the side of a room, and we were at a nice honorary thing, and we said, geez, we had no idea all this would happen. Jeez, who the hell knows, you know? But so it's hard to predict, you know. We didn't know about the cell phone piece of it. Where is it going to end? I don't know. I mean, I think the taking part of this has kind of been solved. I mean, there's some real innovative work going on with, you know, focus-free cameras and stuff like that going on, field imaging cameras. So I think there's more work to be done, but images, the pixel wars are sort of over. I mean, you can argue, go buy your 14 megapixel camera if you want. don't know what you do with them all, but I mean, so I think that's been solved, but I think there is a problem. I think there is a problem with storage and retrieval. I think people are working on that, facial recognition, things like that. You can find all these images. We're taking more images today than we've ever taken before. What do you do with them all, right? And then for places like this, the challenge is the archivists. How do you maintain the integrity of these photographs over a period of time? I think that's a real challenge, and I think the archivists are struggling with it. I guess when you solve one problem, you create another one. That's what innovation's all about. So that's the answer.
Thank you, Steve.
Thank you very much. Thank you.
And thank you for attending tonight's lecture. Please join us next Wednesday, Nolan Gasser and Pandora Music. Thank you. Good night.